So I would like to use this video in order to introduce some utilities that we can use with functions. And I want to start with guards. And you can think at guards as kind of a series of if-else chain. And we define guards by using this pipe followed by some condition that will evaluate to a boolean. That's why I say that are similar to a chain of if else. And when one of these guards evaluates to a true, then the function is substituted with that expression. If that is false, it goes to the next guards. And if that's true, of course, evaluates to that expression and so on until it reaches something that evaluates to true. And I can show you that this otherwise always evaluates to true. In fact, you can think of otherwise as true itself. You can even directly write true here, even if the Haskell extension will get mad since he wants you to use the feature of Haskell. And here I've defined this function called end2string, which takes some integers and transform it to a string. Now there is already a function in Haskell that does this, and it is called show, which given an integer or a number returns the string number. But here, as last case, I've defined this expression to be evaluated, and this expression is just a recursive call to this same function to the integer division of whatever number that, if we get here, are sure is greater or equal than 10. So the integer division of 10 by 10 is of course 1, but the integer division of 12 by 10 is also 1 since it gets rounded. And then I use this operator, which is a concatenation. And now in other languages you can use just the plus as operation to concatenate two strings, and we know that strings are arrays, so this is an operation done with arrays. In any case, in other languages you will do something like an array and then plus and then an array. Now in Haskell this is intended of course as a different operation than the plus, so you would have to use a different operator. And you can also, if you want, ask for the type, but is nothing exciting, is just something that given two arrays returns a new array, and of course the resulting array is the result of unifying the two arrays given. And so I'm doing this concatenation between the string version of whatever is returned of the integer division of the number and the string version of the modulo of the number in base 10, which returns a number between 0 and 10 based on what's the last digit in this case of the number given. So this is how you would use guards in order to define such a function. But now I want to use the rest of the video in order to try to explain this expression right here, which may seem cryptic at the moment, but we'll break it down. And we'll start by using GAC. As always, when you find something that you are not sure what is doing, always go to GAC. And we'll start by asking for the type of map. And we see that the type signature includes some parentheses, and we'll get to these parentheses. But for now, we see that we have something that goes from an A to a B, and then we need an array of A, which are the same type of the input of this, and then return an array of B. Now, if you come from any other programming language, it's very likely that you have already encountered something similar to map. In fact, this is an higher order function, and higher order functions are called so since they take function as inputs, and this is exactly the type of a function, and it is wrapped inside parentheses because the operator that defines function is right associative, and we saw this while talking about partial function application. We saw that in Haskell we only have something that goes from an A to a B. So we have only function that can take one argument, and implicitly we do have parentheses starting always from the right. So this is how a type signature of a function is interpreted. But when parentheses are present in a type definition like so, then we are asking to first evaluate this as always. And this means that this is actually a function that we need. And it is, of course, different than asking for a function that takes 3 arguments. But this is actually a function that takes 2 arguments, of which the first is a function itself. And so we are defining a higher order function. And so we see that map is a function that takes a function from A to B and a list of A, and we can assume that it applies this function for each element of the list, and that's exactly what happens. In fact, we could have defined the add_choose function from the previous video, but only by using this map, since all we were doing was actually just to iter over an array, and we would have just done map +2 to a list, and the result would have been the same. Now, this +2 between parentheses is using the partial function application with the plus operator. In particular, the plus requires 2 numbers, but since we only gave one here, then we see that the type of the plus operator is, of course, something that takes 3 numbers. Here is signed with A, but we know that A is a number. And if I provide already a number, we are returning something that is a function from a number to a number. So this right here is just a function that adds 2 to a number. So by writing map and then this that we know is a function, and in this case, since we know that this function takes a number, so we at least assume that this A must be some kind of number, and it must return also a number, since this function returns a number. And since returns a number, this B must be a number, and therefore also this B must be a number. And we can ask if that is true to GAC by asking the type of map provided with this function, and we see that it only requires a B to be a number, and map +2 is just a function from a list of numbers to a list of numbers. And so we could have defined this add_choose, which is a function from a list of integers to a list of integers, as add_choose is equal to map +2, which returns a function, and so we are storing a function inside this. And notice how we didn't need to specify add_choose list and then provide list once again here as argument, since it is implicit from the moment that map already returns a function. So we don't really need an argument here just to reprovide it here. So we already explained what this map is and also what this is, but we really don't understand this part of this expression. Well, actually, we don't understand this $sign and this dot, since this is a function that we define here, and it is something that goes from an integer to a string. So we can ask for the type of this dot here, and we get that the type of this dot is maybe quite complicated first, but let's go through it. So this dot takes a function that goes from a B to a C, and we know that this is an higher order function since we wrap these functions inside parentheses. So here we are taking a function as an argument that goes from a B to a C, and then here we got a function that goes from an A to a B, and this B must be the same of this, of course, since we gave the same name for the type. And then it takes an A, and when provided with these 3 arguments, it returns a C, which is the same type of the return type of the first function. And so we can assume that this operator kind of chains these 2 functions. In particular, first calls this first function, since the only thing that we have different than a function is this A. So we must assume that is calling this function with this as an argument, and so we get a b back. And when we get a b, then we can apply this to this function and get back a c, and then we get the result type of this operation. So we just discovered what this operator does, and it just chains two functions. In particular, here, what we are doing by writing this, well, we know that this is a function that takes an integer, so we must provide some kind of integer. So what we are doing here is just doing this, requesting to first evaluate this function with the given input, and this results in a b, and then we are passing this b inside this function, and this function will return a c. So writing this, oh well, actually we don't have the function loaded here, but as I said before, we can replace this with show. So what we are doing here is actually the same of this, and here we first get a function from actually a to c, since we provided these two parameters. So what we got by calling this expression is just a function. Actually, it already says to us that c is a string, but what we got is just something from a to c. So what we are left with is just this $sign, and as always, we can ask for the type of the $sign, and we see that this is another higher order function that takes something from an a to b, then an a, and returns a b. And from this type, we could assume that this function is just taking this a and applying something that would return a b, and then return a b. So it seems that this operation is not really doing something, since only applying this function would have already have returned a b, but this is not actually true, since, well, of course, using this operator like this does not really does much, but we could use this operator in order to stop the function to be greedy. In fact, this operator does have the precedence over the function, and so since this takes a function as an argument, then this is treated as an argument, and the following also is treated as an argument. And in fact, without this $sign here, this call would have been an error, or at least it would have not been interpreted as intended. In fact, here we are first doing this and then multiplying by 5. So 4 by 5 is of course 20. But say here we had this show, then of course here we are first showing this 2, which results in a string, and we cannot really do an operation between strings and number, and that's the same error as above. And so if we had to use a show here, we could have done this by using parentheses, or we could have used the $sign for shortness. And so that's what this $sign is doing. It's just a way to force the evaluation in maybe some less syntax. And with this, we should now be able to understand what is going on. Here we have a map, and once again, the type of a map is something that takes a function and a list. So here we have a map, and then we expect some kind of function, and we are using this $sign in order to first evaluate this expression, and this expression does have a dot here, and so we know that is chaining this function with this function, and this function, we know it takes an integer, which is the type of this, and returns an integer. And this function, we define it above, and it takes an integer and returns a string. So this is creating a function from an integer to a string, and then once map does have its first parameter, it returns something that goes from a list of integers, since this function we got here is something from an integer to a string. So here we must have some integer, and then returns a list of string, since this of course returns a string. And here we got already a function that is valid for this type signature, and so we are storing the result inside this variable, which is a function and doesn't need to specify the argument, since it is of course already a function, and the argument will then go directly here once it is provided to this function. So in this video we had a look on how guards works. We saw what this map is doing. We reviewed once again the partial function application. We saw what this dot is doing, and this is the composition operator, which is composing two functions in order to create a new function. We also saw how to avoid some parentheses by using the $sign operator, and then once again by using partial function application we saw how it is possible to not always make explicit the parameter of a function when we already do have some kind of function as a return value. So if you learned something in this video, consider to subscribe to the channel and do not forget to like the video. If you want to support the creation of this content, you can delegate your ADA to Harmonic pool and earn interest on top of supporting this series. But whatever you chose to do, remember that the most important thing that you can do is to stay decentralized. In any case, I want to thank you for your time, and I will see you in another video. Bye bye.